Yo, what's up everyone? So we're on day 2 of our second unit. We're in week 8. This week we'll have 2 problem sets and no quiz because we have a short week. And we're not going to finish the unit or anything this quarter, but we are going to start it. So hopefully you guys are on top of everything, and we got to continue learning because I feel like with all the grading stuff, things have moved pretty slow recently. But we got to get to our second unit. So we're talking about quadratics again today. And you might notice some things you hate, like domain and range. But the point of today is to try to figure out as many shortcuts as we can when graphing quadratics, which are in the vertex form. Okay? And something that I'll say even before we start that's good news is that, domain and range are like some of the hardest concepts for most students. But if you continue to watch the videos, like, these topics are going to make sense. And I put them in the beginning of the year. I introduced them at the very start because we revisit them pretty much every unit, and it's going to get easier every time. So just because we didn't perfect domain and range the first time, like, I'm not personally worried, because if we keep talking about it, you're going to understand it. Before we do that though, we're going to talk about all the things that our equation gives us that could potentially be used as shortcuts. Okay? And the most important, which we talked about last time, is the vertex. Okay? So your equation potentially has 3 numbers. There's a missing number on the outside here, but then we have a number connected to x and a number on the outside of x. Those 2 numbers give me my vertex. The vertex is h comma k. And to do that, all you do is flip this number, the x value, and keep the y value the same. So if we want to write the vertex, we see -4, so we flip it to +4, and we see -6 and we keep it. And it goes x then y, and x is what's connected to the equation. So hopefully that makes sense. And when you have that point, the whole thing starts to become clearer. Okay, this is going to be your vertex, so it's going to shoot up or down from this point. And then once we have that point, we can put the vertex into my chart. Now, after today, you might be able to skip the chart a lot of the time. I still want you to fill it out for those points, but we're trying to find some more shortcuts. Okay, before I find them, which are going to relate a bit to the slope, let's do what we do know how to do, which is always make a table if we're trying to graph an equation. So if this is my middle point, I'm just going to put points above and below it so that we have those points right next to my graph. So 2 and 3, then we have 4, and then we want 5 and 6. And then we know that if we find these two are going to have the same y value because it's symmetrical. So all I really need to do to start is plug 2 and 3 into my equation. X is the input, so we're going to put that value here, and then we're going to solve its y. Okay, so again, that's your basic technique for graphing always. Plug in points. We found 3 points, so let's plot those. We have 3, -5 and 2, -2. Good, perfect. And what you should realize at this point is that the shape is always going to be the same. It's not a straight line, but it's a U or a hill. So once you have the one side, we know that the other side is going to look the same. So at 5, y is -5. At 6, y is -2. And then we can draw up. Okay, and that's not the best drawing, but I think that's fine. But we're going to talk about some of these properties here. Now that we have it, let's talk about ways that we could have done it quicker. The first thing that we're going to talk about is the axis of symmetry. I'm going to skip the slope for now, but our second shortcut is that we know that both sides of my graph are the same. And hopefully you know what symmetry means. it means that two sides are the exact same. So a good method, I don't know why I have my hands out, but like a good method is always think, could you like fold it and have both sides be equal? Okay, and that's always true for a quadratic. And what's good and interesting, I'm going to draw this little line in, is that when you have symmetry, you can say that the symmetry happens around a line or about a line. So if we're looking, this side and this side are the exact same. If I were to fold my paper there on this line, both sides are equal. So if you're ever asked what the axis of symmetry is, you're trying to name this vertical line. And as a quick side example, last unit we did a lot of horizontal lines, which are functions. And if it's a horizontal line, the equation is like y equals a number. But if we're trying to name a vertical line, it's going to be x equals that point. Okay, so we go slow and then everything gets revealed. But in this case, if we want to write what this line is, the x value is 4, right? 1, 2, 3, 4. X is 4 the entire time. So when you write it, we're going to say x equals 4. And what's a really important and crucial hint here is that the axis of symmetry is going to happen at the vertex x, right? So you could find this axis of symmetry just by taking what's next to x and flipping that number. We know that the vertex x is 4, so the axis of symmetry is x equals 4. Hopefully that makes sense to everyone. The final part, and this first question is mostly review, and we're going to touch on this next one, is the slope. Okay? And if you're a master's student, if you're crushing all of this, this is how you're going to shortcut every single equation so that you don't need the table. And the key is it's going to be whatever number is on the outside of my equation. And I start with an example without one because this is really important and something that I probably haven't stressed enough. But if there's nothing here or there's no slope, we have to think, what's the implied number? The implied number is always 1, okay? A single x minus 4 squared is happening here, right? There's not 2x minus 4 squareds, there's not negative 3x minus 4 squareds, there's a single 1, okay? So if you don't see a number here, your slope is 1. That's the implied number. So math is a lot about the implied numbers sometimes, and what that number is going to tell you is how quickly you move up or down. And it's always going to be the distance between the first point and the next two vertically. So what I mean by that is that if we started here and my slope was 1, the next 2 points are going to be just 1 up from there. And we'll expand upon that in the second example. But hopefully that makes sense to everyone. I think that's pretty cool. So the slope here is 1, and now let's talk about domain and range. And I've been thinking a bit about how to explain this a little bit better. And the way that I want you to think about this, and the good news is it's really easy for quadratics, is your domain, you're just looking at your graph from left to right, okay? And what makes it so hard is that whenever you have arrows, they're almost always pointing in 2 directions, even though they both appear just to go up, okay? But if you're looking at these arrows, and these arrows you draw in mostly, it's really important to recognize that this arrow is going up, but it is also going a little bit more left. And that's really important because this arrow is going up forever, right? And that's easy to see, but it's also going left forever. If we continue to draw this line, it's slowly going to the left. So it will make it all the way to negative infinity. Okay? And you know, domain and range is a concept I half memorize, half understand, but it's like 90% understand if you can really get it. But because this graph has no breaks, it's going to be negative infinity to infinity, because this goes forever this way, and this goes forever this way. The one that's easier to understand, I think, is the range in this case. And we know that if domain goes left to right, range goes bottom to top. And it should be more obvious here because we just have to look to see where are the missing points. There's no points here, right? So the lowest possible y value is this -6. It will go forever, right? There's no doubt that infinity is possible, but -10 isn't possible, okay? So we'll use a closed bracket for the point, because it does equal -6, and then it goes up forever. So in this unit, and if you're watching, this is good because you'll feel really solid, the domain is pretty much always going to be -infinity to infinity, and the range is going to be like a number to infinity or -infinity to a number. There's not going to be a lot of u's in this unit. Okay, so that was example number 1. Hopefully we felt pretty good about it, but we're going to tackle at least one more now. And the real goal here is to dominate this kind of slope number. So, you can honestly try to do as much as you can before I go, but I'm going to, just go through my technique, which is first identify the vertex, 3 and -5 the numbers we see. So we flip that to -3, comma -5. Then we put that point on my graph, and then I start to visualize where it's going, okay? Once I have my first x value, I just want to try to find the 2 this way and the 2 this way. So -5, -4, etc. And even here, we know that if this is the vertex, oops. If this is the vertex, it's going to be symmetrical on this line. So as we draw, we'll notice that, but you can find this very, very, very quickly just looking at the equation. Now it's time for our second shortcut, okay? And that's what happens if we have this outside number, which in this case is 2. So the slope, and I call it slope, but that's not even a technical word for it. There's not a really good technical word for it. What the slope tells you is how you're moving from the vertex, okay? And just keep in mind, you always can use a table. It always will work. But the slope method is really fun in my opinion. So if this is my vertex and the slope is 2, that means that my points on both sides are going to go up 2. We know it has to be the same on both sides because we're symmetrical. And because the slope was 2, each way is up 2. And before we go any further, let's compare to the first one. The first one, the 5 points we had were these 5 points, and the slope was 1. So the slope told us that each way we go up 1. Okay? And then after that first point, we went up 3 more. Okay, so that's going to be interesting for the second part. Because, and you should write this down, a typical graph goes up 1 and then up 3, but you got to multiply that by slope. Okay, so if the slope was 2, you first go up 2, and then you're going to go up 3 times 2, so 6 more. Okay? And hopefully that makes sense. We have our whole graph. And how this looks different from the last one is it's going up twice as fast, right? You go up 2 and then up 6. Our graph is expanded as the slope gets bigger, just like with a linear equation. So think that this number, this outside number, tells you how rapidly you go up. Because the slope was 2, we're going to go up 2 and then up 6. So that's what it would look like. So that's how you use the shortcut, and I still want you to fill out the tables just for now so that we can be really technically strong, but the 2 points here are -3 and 3. Let's do quick domain and range so that you see how easy this is going to be from now on. There's no breaks at all in my graph, so it's going to continue both ways forever. So because there's no piecewise, the answer to domain is always going to be negative infinity to infinity for the whole packet. Then the range, what's important here is that the lower bound of the upper bound is going to be the vertex. So if my vertex is -5, we know no point is below -5. So it's going to be -5 to infinity. So hopefully we see that as very similar to the first one, and it's not going to get too much harder than that. Okay, really good work. I am going to do a third one just so that we master this. And we're doing really well on time. And all I want to do to master this is talk about one more slope value. Okay, so now every time you see an equation, you have 3 numbers, and those 3 numbers are going to come into play with your properties, right? The vertex is the first number flipped, then the second number. The slope is the outside number, so -3. And the axis of symmetry is the x vertex value, so -4. Then we already know the first point we put here is -4, 9. And then we want the 2 points on both sides from there. I went through that quickly just so you can see how quickly you can get this done now that you kind of understand everything happening. We'll plot the vertex first. -4 up to 9. So this is my vertex, and we're going to now use the slope. And if the slope is -3, it tells me that from the vertex, both directions, I go down 3. Okay? And in this case, it's almost like it's a hint, because you can't go up with this being the point. So this number tells you where you go from the vertex. And if that if that slope now is really big, in this case -3, you're not going to see anything bigger than like 4. And the reason is this is going down a lot, really quickly. So you always remember that if it originally goes up 1 and then up 3, we have to multiply that by the slope. So now we go down 3 and then down 9. Okay, so originally you'd go up 3 the second time, but now we go down 9 more. So that's my graph, and let me just sketch it in. And I honestly think it's really hard to graph these, but if you practice, you get better. So it's worth taking seriously. So we have the graph. It sucks, but let me put the points in here. We have 2 values, which are 6, and then these are -3. So if you know the shortcuts, you never need to plug into the formula again. But if you don't, this is always your backup. And I feel really good about this lesson. I think hopefully that makes a lot of sense. But let's finish it up with domain and range one last time. This graph is not stopped either direction, so the domain is -infinity to infinity. And then the range here is going to be slightly different because we're going down and not up. So compared to the other ones, this graph is going down, meaning that it's going to reach -infinity. It's not going up forever, it's going down forever. So -infinity we put first, and we have to put it all the way until it stops. So this graph will never go above 9, right? Nothing's ever going to occur above that. So I put 9 here. And this range indicates that my graph goes from -infinity all the way to 9 on the y-axis. Alright, that's that. Hopefully it was good, and I'm proud of you. Woo.